Hello. In this video, we are going to transform a free particle wave function that is originally written in an exponential form and then write it in a trigonometric form. The reason why we want to do this is that when we derive the free particle wave function for the particle in the box, it is simply easier to do in the trigonometric form than it is to do in the exponential form. So the first step is to recall that we can interconvert the different wave functions in the following way. That if we have the sine of kx, we can write this as e to the I kx minus e to the minus I kx divided by 2i. Therefore, if we want to write c times the sine of kx, we simply multiply the left-hand side by c and multiply each term of the right-hand side by c. And that gives us the following. We get that c times the sine of kx is equal to c over 2i times e to the I kx minus c over 2i times e to the minus I kx. Now for the next step, again, recall that we had derived an expression for the cosine of kx. And recall that that was e to the I kx plus e to the minus I kx, all divided by 2. So therefore, if we want to get an expression for d times the cosine of kx, we multiply left and right hand sides by d, and we get the following expression: d times the cosine of kx equals d over 2 times e to the I kx plus d over 2 times e to the minus I kx. Once we have done this, if we want to figure out the coefficients c and d, we notice that the coefficients of e to the I kx here have to be equal to the coefficients here. So if we're going to add together c sine of kx plus d cosine of kx, well, we can look at our expressions here, and we know that we have to make this coefficient a, the coefficient of e to the I kx, equal to the sum of the two coefficients here. So that tells us that a has to be equal to c over 2i plus d over 2. Okay. Now similarly, using exactly the same sort of reasoning, we can figure out what the coefficient b has to be. So b, because b is the expression to get the cosine of kx, so we notice that for d times the cosine of kx, the coefficient of e to the minus I kx is d over 2. And the coefficient in the c times the sine of kx part is minus c over 2i. So now we've been able to write the constants a and b in our equality here in terms of c and d. And the next step, what we want to do is be able to write the individual coefficients c and d in terms of a and b. So recall that a we found to be c over 2i plus d over 2. And we also found that b was equal to minus c over 2i plus d over 2. And if we write it this way, it makes it somewhat easier to find the sum and difference of a and b. So we notice that if we add a and b together, so let's try a plus b, what do we get? Well, we notice that c over 2i and minus c over 2i, when added together, cancel out. So we get simply d over 2 plus d over 2, which is equal to d. Okay? Now, if we subtract a minus b, notice that just taking the d over 2 terms, we have d over 2 minus d over 2, so the d's cancel out. And then we're left with c over 2i minus a minus c over 2i. So you get c over 2i minus a minus c over 2i. That gives us 2c over 2i, which is simply c over I. It tells us right away that the new coefficient d is simply the sum of a plus b from our original free particle wave function. It's slightly different to find c. So to find c explicitly in terms of a minus b, we recognize that if we multiply both sides of our equality here by I, we get that a minus b times I equals c. So we have an expression for the coefficient c in terms of the previous coefficients a and b. So that gives us our coefficient c, and we've noticed up here we derived that d is simply the sum of the coefficients a plus b. So in summary, what have we accomplished? What we've accomplished is we've shown that we can take any free particle wave function that's written in an exponential form with coefficients a and b and rewrite it in terms of the trigonometric functions, the sine and cosine, with the appropriate coefficients c and d. And even more than that, it tells us exactly what these coefficients have to be if we already know what the coefficients a and b are for the exponential forms. Thank you very much for your attention. Have a good one.